flag, so we can answer to your questions once we are done with the live streaming. Okay, so over to Jeevat now.
Yeah.
5, 4, 3, 2.
Let me know if you can.
Good morning, everyone. I am Jivraj Pillai. I am the president of packaging.
So, just a minute. Can you see him? No. You have to click the link, the YouTube link.
We're on air. We're live now.
Yeah.
So let me know once you see him on that link, YouTube link.
You have a delay. That's normal.
He will start the presentation once you say yes, you can see him on that YouTube link. It's in that invite that Kanika has sent today.
Estoy viendo y dice que sí.
नहीं दिखने दो क्या
You
फर्क
see a link? Yes, that's where you got to go. You may see now. You may see it's live. Right now it's live.
That's live now with the music and everything?
Yes. But can you see him, Jeevraj?
I don't see him.
Let's go over because I'm looking in 3 different places and I'm not finding it.
Okay.
I hit the link, but it's like it feels like it's
Okay, 1 second.
म्यूजिक के बाद आएगा.
Okay.
I guess I'm not finding the link.
Okay. Invite, yes.
So guys, that link is for your basic it looks like a marketing video on YouTube. It doesn't feel live at all.
Yeah, we have not started. But only thing is, can you see him? Is the question. We can start the live streaming. No, they're not able to see.
I saw you before.
No, we can see. 1 second. 1 second. We can see it, but I'm sending it to Greg. I email Dennis.
I've got it open now on YouTube.
Can you?
So there's another link.
एक और मत-
I sent you another link.
So I went into the Microsoft Teams and I opened up the invite. Now,
तो कुछ बात करते रहो.
Dear Greg, it says please find the attached link for live stream.
I'll send you the link. That's the one.
I have also sent an email to Joe, you and Greg. Just let me know if you
Chat
received
में
the
वो link
email.
डाल दो ना. Zoom की chat में वो link डाल दो. Everything will see it.
Can you share with the team, please? Can you please share with the team? So let us start. Let's talk. I mean, why don't you talk a little bit and then see if we can see him now.
Just see a picture, no, so I can
So
not so much to talk.
वो link
इससे बात
Zoom में
करो.
paste कर दो ना.
कर दिया सर, मैंने कर दिया.
जो मैंने भेजा ना सर.
हाँ.
So as soon as they
Okay,
see
now
me,
you got it live on the link. Everyone. Oh, okay. No.
So if you're on YouTube, up in the top right-hand corner, you'll see I got it. Just go into the board. Oh, I got it.
इसलिए बोला था आपको मैं.
I got it.
But it's a good. We are trying technology at a way. Trying to save your time to come to Tampico.
See these guys.
Okay, now you can see us.
Yeah, I can.
Anybody still waiting to connect?
I am struggling, guys.
Joe, hey Joe, you know that if you open that video if you saw that marketing video, and go on
7
the
people
upper
are
right-hand
viewing the
corner
link.
of like your YouTube videos, you probably should see a list of videos.
YouTube में.
Live, and you can click on
I think they're connected now. People are viewing.
Okay. वो यहाँ पता चल जाता है ना.
Dennis, can you see us?
उसमें से 4 तो हम ही हैं, 4 तो हम ही लोग हैं.
Okay, can we start? So can we start? Okay, so here we start again. So you're focusing now on Jivraj. So Jivraj, please,
Yeah.
over to you.
Yeah, good morning everyone. I am Jivraj Pillai, President of Packaging. I will be your host today for this plant tour. We are at the woven UFLEX woven plant here. This is built on a 10-hectare land. You can see from here we have about 670 meters of land, and we have built this in phase 1, which is 1/3 of the capacity. This plant can produce about 7 million bags a month, which is like over 80 million bags a year. We will take you through the plant tour. I will go inside the plant. So this is a state-of-the-art plant. We have used the latest technology in many places on the front-end devices. We have used AI also to store some recipes and to bring them up when the job is repeated. You see this plant, we have this beautiful entrance here. So essentially we have 2 entrances. One is for the workmen and this one is for the visitors. We will be entering the plant through the visitors gallery. Yeah. Okay. So this is the main gallery. So we have the marketing offices and the design offices on the first floor, and we have the admin office on the ground floor. So we are walking through the gallery. So basically this is designed with 2 lines of defense. The first line of defense is the outer area of the plant. The core plant is in the inside line of defense, which we call, so that we keep this dust and the contaminants away from the core area. So this is the design aspect of this plant. So you are in the outer line of defense at the moment. So now we will enter the plant. So this is the end of the process actually. So this is the area where we make the bags, and we will go right up to the front of the plant where we make the fabric. But right now we are seeing the end of the process. We are entering into the laboratory. So this is a very full-fledged laboratory designed for testing the woven polypropylene bags. So we have all types of equipment. We have the heat sealer, we have the COF testing machine, we have the stiffness tester, we have different types of COF testing machine, we have the tensile testing machines. We can test the strength of the mechanical strength of the woven bag. We can also check the strength of the seam. This is a hot air seam which we have done on a diamond V bag. It's beautiful seam. You know, there is no glue here. This is hot air. This is also hot air, unlike the competition which uses glue here. We use a hot air sealing system, and this is the seam strength is tested here. The mechanical strength of the bag is tested here, and we do all the drop tests and all the abuses which we can do as much as possible on the bag before we ship them out. So this lab is also following ISO 14000, and this is fully equipped with all the types of equipment which are required for making a good quality bag. So here you see a tape which was made in the plant, and this is a tensile tester. So it begins with testing of the primary material, which is the tape itself. And once the bag is made, the bag is also tested on a tensile tester you see on my right. So all the ingredients of the bag follows a standard SOP defined in the quality system, and the testing is done as per the defined standards. So now we will be going to the bag making process. We have the latest generation of B&B bag making machine. This is a high speed line, this runs at about 80 bags a minute and it can be pushed up to 90 bags a minute. Now you can see the unwinder of the machine. So this is where the roll is unwound. And here we have two shafts, so we can run the machine without actually stopping the material, the web flow. So unlike the other systems available, we don't use a laser system to create a profile. We use a mechanical tool which is more reliable to make the perforation of the step cut on the bag. This is a unique system which we have here. This is a combination of B&B and Miller. So this is a Miller hot air seaming device. So the seam is sealed through hot air. This has been integrated. There's a beautiful coordination between the Miller system and the B&B system. It gives you the right temperature and the right sealing profile. And this is so well designed for every bag size. The speed, the temperature and the pressure is automatically set. So this is the unique part of the bag making machine. So there is a metal detector as a quality system. So as you can see, now the bag is cut and ready for the bottom seal. The bag is already formed with a seam seal. It is now going for the hot air system for the bottom seal. So this is where we do the bottom seal. And this is the bag which has come out. The beautiful alignment. All the bags have a tolerance of plus minus 2 millimeters. You see, the cutting is beautiful. There are no strings coming out. The picture is well aligned, and it's a beautiful looking bag. Here is another aspect of this machine which is very critical. This has got two gates. One is a reject gate. If the bag is not as per the quality standard, there is a reject gate. The bag will go upstairs. It will climb on this platform where we can store the rejected bags. So it's an online QC. This was developed with B&B. We have defined the defects, what kind of defects which we cannot send to the customer. So all those bags which have defects will go upstairs in a reject gate. Yeah. So this machine can produce about 2.2 million bags, and we have space there for two more lines. One line is getting installed in end of May. Second line, and the third line will be installed end of June. So by July we will have all the three lines positioned here and producing about anywhere between 6.5 and 7 million bags. We now go to the previous process, which is the laser engraving. So here what we do is create vent holes by laser. So the half moon or the smallest size of holes are created to remove the air from the bag when it is filled, and the holes are so designed that it does not enter, it allow the mites to enter the bag. So this is the device where we create the laser holes. This is for taking the air vent out. So I can show here, this is a half moon which is cut through a laser, and this laser is 200 microns. So the mites do not have the power to get into the bag through this hole. So this is done through laser, so it's very accurate. So we have two machines for laser, and all our bags are equipped with this facility. So the laser vent hole is a beautiful thing which we have developed over a period of time. Generally competitors do through mechanical holes, but we do it through a laser process, so that every hole is controlled, entire air is taken out, and you don't lose any speed on the filling lines. So as I said, we are going in the reverse direction. So we had bag making, we have laser, now we'll go to the slitting line. So in this plant we always wanted to do something new, use high tech, and that is why in the slitting line we have used ultrasonic slitters. So unlike regular blade slitters, we use the ultrasonic tool to cut for a reason that, you know, when you cut it through a razor blade, you have the threads coming out, and this is not good for the pet food. Sometimes the threads can go into the food and get the food contaminated. So here we use a laser system where you can see the cut is very clean, you know. You can see the system which is very clean cut, no threads hanging out, no, we call it as angel's hair. This is very dangerous for the when it gets contaminated with the pet food. So this is a new system which we have developed. So now the previous process is lamination. So as I said, we are going in a reverse direction. We saw the bag making, laser, slitting. Now this is we will show you lamination and followed by printing. So here we have a laminator. Now as I said, we wanted something new to be done to the process. So we have a primer coating unit. This you would not find it anywhere else. So this is a primer coating machine unit which gives you an adhesion which is beyond 500 grams per 25 millimeter. So this is very essential. We have a coax line. So we have BOPP coming from one side, woven fabric coming on the other side. The BOPP is primer coated, so you get very good adhesion of the between the BOPP and the fabric. And this is a beautiful machine running at about 300 meters per minute. And you know, you see on the screen there is a gauging system. So we try to control the extrusion coating within 1 plus minus 1 GSM. A process previous to this is printing. We'll now go to the printing section. So this is the printing machine. This is a Flexo. This can run at 400 meters per minute. This is a 9-color press. So this is 8 color on CI and 1 color on as an inline coating. So here we can do matte coating, we can do registered designs, we can do embossing, many things, many printing features can be put on this bag. So right now we are printing a matte finish OPP. As I said, this machine runs at 400 meters per minute, and this is the first machine which can run at 400 meters per minute with water-based inks. We don't use any solvent here. This is a water-based ink system. As we all know, all the processes are directed towards sustainability. So water-based inks are the most sustainable ingredients which we use for the bag. This is how the press was designed to run at high speed with water-based inks. Another interesting feature on this machine is that we have built in a little bit of AI here. So if I am printing a diamond V job, and if I store all the recipes inside, the ink GSM, the analoxes, the pressures, everything can be recalled when I get this job again for printing. So this is a beautiful part of it. You don't have to, so the repeatability and consistency is always there. So this is the CI section. As you can see, we can print up to 50 inches. You know, this is the longest repeat which we can do is 50 inches. You can see the print quality. So beautiful print quality is photographic. So the conversion stops here. So we have printing, lamination, slitting, laser and bag making. We also make our own fabric. So we will now go to the fabric plant where we will be showing you how we make the fabric. This plant is under installation. Rest of the process has already started. This is likely to commence operation from 1st of May. So we have 53 looms and a very high speed tape line, and this 17 looms are under installation, will begin operation from 1st of May, and rest of the looms within a period of 3 to 4 weeks. Now we'll walk towards the fabric manufacturing area. So as you can see in the building, this is isolated because when you make a fabric there is a lot of dust. So this conversion section is isolated, is fully air conditioned, and the fabric section is demarcated by a wall. So now we are entering the fabric section. It's a very large hall where it can accommodate about 53 high-speed looms. We have the capacity to make about 5,000 metric tons of fabric, and this is good enough for 6.5 million bags per month. This is phase 1, as I said. So we are approaching the tape line. So on my right is the tape line. This can run in various deniers, various size of the thicknesses. We run from 55 GSM to 72 GSM. You know, we always believe that a 55 GSM fabric can take the load. Why offer a 72 GSM? Thereby we can offer more sustainable and a more economic product. So this can give you an equivalent strength of at least 15 to 17% higher than the conventional bags. For example, if I am using a 72 gram bag, I can make a tape with 65 GSM and will give you the same mechanical properties. So this is the beauty of this line. So these are the goddets which are designed with preheating, heating and cooling, and that gives the strength to the thread. And on my left are the looms. So as I said, the 17 looms are already installed. This will go into operation from 1st of May, followed by another 17 and another 19. So in this hall, we will be able to put about 53 looms starting from 15th of June. Yeah. So this ends the tour here. So as I said, we saw the bag making process, we saw the lamination, we saw the slitting, we saw the laser, we saw the printing, and finally we were able to see the tape line. So this concludes my presentation today, and I thank everyone. I really appreciate your time, and if you have any more questions, we will again join back on the Zoom call. Thank you so much.